as I recommend always, I would myself have a piece of paper writing notes to self. This is not easy mathematics by any stretch of the imagination. If an image on a computer screen is increased by 50%, then its area increases by what? So it wants what percent does it increase? And I guess the best way to do this is the long way. We can do it real fast again, as we've done it before. It doesn't tell you the size of the computer screen, so you get to make up your own. You just know that it's increased by 50%. So, Elijah, what would you pick to be? Here's your computer screen. Let's make it a square just for fun. What would you make it? 10 by 10 is fine. So if you increase 10 by 50%, that means you take 50% of it and increase it by that. What is the new computer screen? You're taking half of it, 50% of it, and increasing it by that. Your new computer screen is 15. We're talking about the area, correct? It's pretty easy to find the area. What's the area of this one? What's the area of this one? 225. Now here's where it might not be a bad idea to draw yourself a table here. You've got your original, then it's increased, and you've got your final. Here's your percent, here's your actual. The beauty of doing 10 by 10 is that your percent and your actuals actually match up to be the same exact thing. My original percent is 100. I don't know what my percent increase is, and I don't know what my final percent is, but I do know my actual numbers. I know my original actual number is 100. I do know my final number was 225, which means my increase, how much did it go up? 125. And because these numbers are the same, this number is going to be the same, and this number is going to be the same. And that's where 225, or that's where 125 comes in. It went up 125%. It was a 125% increase. If they would have changed the wording to say what percent of the original is the final, that would be this number. But they said how much did it go up? And when it went up, that's the middle column. This is how much at the end it was. So you have to be careful. The wording gets a little strange, but that's why you write notes to yourself and say, tomorrow's will probably be the same type. It'll probably be an increase in percent. So don't say that you've not been warned, Jen Davis. What can I do you for? I would love to do number one. One is probably my favorite number one on this test. In a deck of 26 alphabet cards contains one card for every letter, including the vowels A, I, O, and U. One card is drawn, not replaced, then a second card is drawn. What's the probability both cards are both vowels? Probability of getting a vowel and a vowel, two vowels back to back. And one of the key things to look is it says the card was not put back after you drew it. So your probabilities change between the two. So the probability of the first one happening, how many vowels are there? 1, 2, 3, 4, 5. How many letters in that alphabet? 26. But that changes for the second one because you took a vowel out and you took a card out. So there are no longer 5 vowels in there, there's only 4 vowels in there. And there's no longer 26 cards because you pulled one out, there's only 25 cards. Probably the first, probably the second. Probability that they both happen together is that multiplied together. And through a series of cross-canceling here, 5 goes into 5 once, 25 5 times, into that twice, into that 13 times. 2 times 1 is 2, out of 5 times 13, 65 times. 2 out of 65. And again, because, you know, if you drew a card and put it back, these would be the same. It'd be 526 for both of them. But you didn't put the card back, so it changes that second draw changes because you're minus a vowel and you're minus a card. Riley O'Harrington, sir.
Can you please explain number 10?
I would love to explain number 10. The only way we get smarter is by. And of course, number 10 would be on the second page of this area. What is the lateral surface area of a cylinder? All right, so let me re-sketch Mr. Cylinder over here. He is a 10 by 20. It's kind of a short squash. And the note I would leave to myself is this. Lateral surface area of a cylinder is just the area of the label, the sides, not the two circles. Alright, and here would be the formula. That means the lateral surface area of a cylinder is the circumference of the circle, which is pi times diameter, times the height of the cylinder. That would be the formula that children that want to do well on tomorrow's test would just write down. And you just fill in the blanks. Does it say use 3.14? It must at some point. What it says up top there, does it? No, maybe not. I guess we still can. So it is 3.14 times the diameter, which was 20 inches, times the height, which was 10 inches. Lateral surface area of the cylinder. So we end up taking 3.14 times 20 times 10, which is 200. 0.00826, 2 decimal places, 628 inches squared. And we might as well, while we're here, the volume of a cylinder is the area of a circle, pi times radius times its height. That gives you the volume of the circle. Same thing as saying the area of the base times the height, which is what our volume for any prism is, I guess. So that would be 3.14. What's the radius? The diameter is 20, the radius is 10. The height is still 20. So this time you're taking 3.14 times 2,000. Which happens to look like it's probably going to be the same thing as this with one decimal place over, was it? 6,280? What did I do wrong? Well, the height was only 10, that's why, sorry. My bad. Too many 10s and 20s. So that would be 3,140. Which is cubed. See, look, you're already going to get a couple of them right. Carol Winkleman. Number 5. Is that on this page? 2, 3, down here. 4, up top here. Don't worry. I've got this down to a science. Oh, these are the lengths. What are the lengths of CE, EF, and FT? Blow this up and make it ever so much bigger. So the first one we're looking for is what? CE? Oh boy, no, I don't want to do that. Please don't. I guess that's fine. Well, in order to do this one, obviously, what do you see here? Right triangle. This is the hypotenuse of that right triangle. So the Pythagorean theorem, a squared plus b squared is c squared. And we hope it works out to be a triple. A squared is 5 squared plus 12 squared. And we look and see, is there a 512 one? Yep, there it is. CE has to be 13. Did I do it right? Doesn't seem the way I read the answers. EF, EF, well, the whole thing is 20, so you take away the 9 and the 5, that only leaves you have to have 6 left over. EF has to be 6 centimeters. And then, what was the last one? FB? FB, okay, you're looking at for a 9 squared plus 12 squared equals C squared. That's not going to be over there, but you always want to look to see if it's there for the smaller triangle that's in the same proportions. What can you divide both of these by? 3. If you divide this by 3, you get a 3 here. Divide this by 3, you get a 4 there. Is there a 3, 4 triangle?
Yes.
Wow, look at that. 3, 4, 5. But 5 is not your answer because this is the small triangle. You have to make it come back to the big one, which means you need to multiply that by 3. And that's where 15 comes from. Expanding it, making it bigger. Laney Kabarik.
How did you do number 19?
Number 19. 19. 17, 18, 19. Oh yes, I love these. This is always a learning adventure for all. If you don't know, this is one of those sticking points it seems like forever for people. I'm guessing, first of all, this problem gets split into 2 parts because of the minus sign between that. You have to simplify this, and you have to simplify this. Pretty easy to simplify that because it's just minus 2, nothing else. This one, though, gets a little more complicated. And what you must realize is that this exponent is right behind what? A parenthesis. Okay, and exponents and order of operations get done before multiplication, so you can't do this times this. You have to do this part first. You have to think about this like this. This is a negative 2 times a negative 2, because that's what this squared is. How many negatives do you see there? 3, making my answer to this negative. And what's 2 times 2? 4. So now I have a negative 2 and a negative 4. This is not multiplication. This is now addition. You have 2 negatives and another 4 negatives give you a total of 6 negatives. I would have thought you'd found some of them in your briefcase.
We'll have some in the briefcase from
Good idea.
now on. Indeed.
Alright, you get that? Order of operations, whatever it is, please don't excuse my dear Aunt Sally or whatever that thing is. You know, the first thing you do, the last thing we do is added these together because of that minus sign. First thing we did was exponent, okay, and then multiplication, and then add. Minus 6 would be the answer. It's tough to remember when you're multiplying and dividing and whatever, keeping your negatives straight. I think it's exciting. Isabel?
Number 15.
Number 15. Is that at the bottom of this page over here? Or is it at the top of this page over here? Oh, one of my favorite problems of all time. Isabel, what did you do to solve that?
I put the x's together.
Perfect. And what do you get when you put 1x with 0.5x? Or subtract 1.5x from 1 minus 0.5 is,
Well, I put
it's like $1 minus 50 cents. This is a 1 in front of here. 1 minus a 0.5. Put a decimal, put a deb there. You end up with 0.5x. It's the same as 1x minus half x. You end up with a half x. And then that equals 1.2. Please don't give your answer in fraction form because it's a decimal equation. They will give their answer in decimal form just because. Does everybody see why you get 0.5? 1 minus 0.5. If you do 1 minus 0.5, you get 0.5. Okay. There's always a 1 in front of the letter. We just don't write it in there. Anytime a letter sits by itself, whether it's an A or a B or a C or an X, it's 1. You just don't write it in there. And then the last thing you do would be divide by 0.5. 0.5 into 1.2. Move the decimal over, move the decimal over, bring it up. 2 is 10. 1, 2, 4. There would be some good notes to solve on that. I'm sure tomorrow's deal is a lot like this. What's 1x minus 0.8x? 2x. Jaden, did you have questions? Was that it?
Yeah, I was gonna ask on 12.
Wait, did we already do 12? Is it on the bottom now? Oh, yeah. Yeah, solving for x. Here is what I always tell people. Okay. That's what? This is done the same exact way you would do something like this. What if it was 3x plus 6 equals, I don't know, 18? You follow the same exact steps. What would be the first thing you do on this one? Okay,
Subtract 18.
yeah, you take the 6 away, right? Well, that's the same thing you do here. You have to subtract the b. The problem with this is c and b's don't go together. You can't actually do the physical subtraction. You just have to write the minus right next to it because you can't put them together. Okay, so now you're left with ax equals c minus b. Just like here, you were left with 3x equals 12. Now, in this one, what do you do to get rid of the number in front of the x? Divide. You write a line and you divide, and you divide. Well, it's the same thing you do with the a. You get rid of it, divide by a, it goes away, divide by a. You can't do any more to that because none of it combines, none of it simplifies. Your answer is just c minus b over a. Just like this was. You know, with the case of numbers, you can always put them together, but here you can't. Same process though. Done the same exact way. Brianna, number 13. Oh yes, here we go again with combining like terms. Remembering again that like terms have to be the same letters with the same exponents. These x's do not get along with x squareds. For some reason, they never have, never will, so they need to stay separate. Here I have 3x squareds, and I'm subtracting 1x squared. I have 3x squareds, and I am taking one of them away. What am I left with? 2x squareds. Here I have 2 x's, and I am taking one of them away. What am I left with? Just an x. You cannot put these together. They are different things. Those exponents make them different. Not multiplication, it's adding, it's subtracting, it's terms. Everybody's happy. Get nervous. Is that on this page? 11, 12, 13. Oh, 14. This was my person who didn't change it into seconds. 30 gallons per hour. What does that look like? This. 30 gallons per hour. That's what you're given, is it not? 30 gallons per hour. I want to make it gallons per hour too. I need to change gallons to quarts, and I need to change hours to minutes. Pretty simple process. You have to do it one step at a time, and it don't matter what you do first. Mitch, which would you like to do first? You want to change the gallons to quarts or the hours to minutes?
Hours to minutes.
Right, so if we do that, what does my unit multiplier have to look like? Since hours are down here, where do they have to go over here?
On top.
And I'm changing it into minutes. And hopefully at the 7th grade level, you know how many minutes are in an hour? So I put my 60 in there. Boom. Cross off my labels, which is my goal. I don't have to, you can do your numbers now, or you can do it all at the end. You could cross this off and make this a 1, and make that a 2, which is fine. Now, my answer is in gallons per minute, which would be half a gallon per minute. Wait, I'm sorry. Yeah, half a gallon per minute. But I need to change it into quarts. So I gotta go back to my gallons over here, use the unit multiplier. Since gallons is up top here, where's it gonna go over here? Has to go on the bottom. And quarts have to go up there. QTS. How many quarts are in a gallon? According to Mr. Gallon over there, 4. Now I cross off my label gallon, which is good. I'm left with quarts over minutes, which is what they wanted. And my 2 goes into 4 twice. The 2 is left on top. Quarts is left on top. And minutes is on the bottom. 2 quarts per minute. What would have been the answer if the 2 would have ended up being on the bottom? Just what happens if when everything crossed off, I had 1 quart on top, not that this is the answer, over 2 minutes on the bottom. How would I say that? I don't usually say 1 quart every 2 minutes. I say, you take the front part of this and you say it is half of a quart per minute. Okay, if the 2's on top like this, it's 2 quarts per minute. But if the 2's on the bottom, it's half of a quart per minute. 2 is on top, so it's 2. How many people got 13 wrong? Because this would be what I'd write on my notes here. Look, I can tell you right now why you got it wrong. 3 minus x is less than 4. To solve that, you should have subtracted 3, yes? Subtracted 3. What are you left with? You are left with a negative x is less than 1. You are not allowed to have a negative with the x, so you have to change it. You make this its opposite. You make this its opposite. But when you do that, you also need to make this its opposite. You change this, change this, change this. All 3 need to be changed. So instead of negative x is less than 1, it is positive x is greater than negative 1. When you graph it, greater than negative 1 goes Rachel. And change colors on the entire boot. Like Van Gogh went through my blue stage. What do my ears look, okay? If he gets that, he will love ears. You got it, come on, I can tell by the way she's. Drew Norquist.
I have a question on number 14. Number 14, what did you do with 4?
What for?
Uh,
Right here?
Yeah.
It cross canceled with the 2 that was left on the bottom here.
Okay.
2 goes into 4 twice, so it turned into 2. Well,
Number 6.
number 6. Number 6. I'm guessing it's over here. Then I guessed the 4. Oh, what is the area of trapezoid? Another thing for your notes is the formula for the area of a trapezoid, which happens to be, area of a trapezoid is 1/2 base sub 1 plus base sub 2 times the height of the shape. What are the bases? Doesn't matter which one you call which one, but the bases have to be the parallel lines. And the height, just like anytime we talk about height with geometry, it has to be perpendicular to the bases, which is this line. So my formula, 1/2 base 1 plus base 2, it doesn't matter which one I put there, I'll put 20 plus 6. Base 1 plus base 2 times the height, which is 12. Okay, now you have to, you can take half of 12 right now, but you can't take half of 20 because it's in parentheses. You have to do that before you go to multiplication. So you actually get 26 there. Half of 26 times 12, half of 26 is 13. 13 times 12, it's at 26 and 15, 156 centimeters squared. There we go. Where did we go wrong on that, Isabel?
I forgot the 1/2 in the front of the formula.
So do it every stinking time. Halves are never the same as wholes. Jaden, 2. Is that on this page? Is that over here? Is that right after 1? Alex figures she saved $12 by buying the item at 30% discount. How much did she pay for the item? Please tell me, Jaden, that you drew one of these nice boxes. Not hearing an affirmative there. Percent discount. You've got the original minus the discount equals the final. Here's your percent and here's the actual. What was the original price? We don't know. We only know that the discount was how much? Yeah, it went down $12. That's how much she saved. We do know our original percent was 100%, right? 30% discount, which means she actually paid 70% for the item, so they have to add it to 100. How much did she pay for the item? That would be the final price right here. So you've got your fraction 30 over 70 equals 12 over what number? Easiest way to do that, Mitch?
You say n equals 70 times 12.
I think there's an easier way. Yes, you could. 30n equals 12 times 7, 840. But I think an easiest way, Elijah, would be reduce. Yeah. Cross out those ending zeros and reduce by 10. How do you go from 3 to 12? Multiply by 4. 7 times 4 is 28. 28 would be your final price. With the magic 8 ball. Not now, maybe later. Anna. Number 17. I love number 17. Ah, someday. Once again, I'm going to ask you how you did this because there's like a gazillion different ways, but I'm not sure which one. But you got it right. Keith Stewart, what was the first thing you did? You could even, you don't have to look at your paper, you just tell me. It would probably be the same thing you told me to do.
Move the negative line up.
Yeah, negatives are not our friends, so you want to change that to a positive. So you put it on the bottom down here, and it's going to be y to the positive 1 power. So it's gone. And then what?
Y's together.
All right, putting the y's together on the bottom. If you have y squared and y, you end up with a. So I got 6x to the 4th. X's are still there. Y to the 3rd on the bottom. On top, I still have 4x squared. Let's see. Oh, plus another x. Then what? Anybody go on? Brianna? Put the x's together. I put those together. I'm left with x to the 3rd. Then what? Grace? But I can reduce my numbers. Cut them both in half. I get 2 over 3. Good with that. Still got stuff I can do. Isabel?
Cross out the x's again.
Right. This has 3 x's on top. X times x times x. This has 4 on bottom. What's going to happen? 1 for 1, they're going to cross off. 3 on the top are going to cross off with 3 on the bottom. And you're still left with 1x on the bottom that doesn't cross off. So it's 3xy cubed still on the bottom and just a 2 left on top. It's so complicated. Mitch! We haven't done 3 yet? Uno, dos. Which of the following is not a characteristic of a graph displaying direct variation? Direct variation and being proportional are the same. Proportional. What do they have to be? They have to go through the origin, and they have to be straight lines. So if that being the case, what does this say? The graph is a line or a line. Which of the following is not? Yeah, it has to be a line, so that's true. has to go through the origin, that's true. The slope of the line is positive. The line has to go through the second and fourth quadrants. Second and fourth quadrants. Let's think about that for a minute. Where's the second and the fourth quadrants? Here's 1, here's 2, here's 3, and here's 4. And the question asks you what? Which is not a characteristic. So we're down to the last two. Is slope always positive of something in direct variation? Or is it go the graph line between the second and the fourth? Elijah Fisher?
D,
Why D?
because direct variation is always going back.
It's always what?
Going back, so impact the slope as possible.
Slope is positive means the line goes up. And like we said, direct variation, as one goes up, the other goes up. If the line goes through the second and the fourth, it has to go down, and that would be the opposite of that, because that would mean as one goes up, as x is going up, y is going down here. Direct variation has to be as one goes up, the other one goes up. So this one here, you can't have. It can't go through those, because that would mean the only way to get something to go between the second and the fourth is for it to be going downhill with its slope. Dorsey could be ringing. Aubrey Altenberg,
Number 7.
number 7. The formula for the sequence is a sub n equals n squared minus 2. What is the 12th term of this sequence? You don't need to know this. This is really irrelevant because you know that the letter n stands for what? Which term? And we know which term we're looking for because it says we want the 12th term. So n equals 12, and that means you just put 12 in for n right there. A to the 12th, which is just the label. The 12th term is 12 squared minus 2. What is 12 squared? 144. 144 minus 2 is 1, 4, 2. You don't even need to know what the is that. Nobody's going to ask on number 8. What's the word of mean? So I'm multiplying 66 and 2/3% times 36 bucks. Well, I don't deal with percents, so I need to change it either to a decimal or a fraction. And in this case, you only have one choice. Maybe Drew, that's where you came up with your odd number of cents. Did you change this to a decimal and make it 0.6 repeater or something? Yeah, you can't do that because you can never do that because it's 0.6 repeater. You'd have to keep writing 6 forever and try to multiply forever 6 times 36 and it won't work. You have to recognize that the only way to multiply with that is to change it to its fractional equivalent, which is 2/3 times 36 over 1. 3 goes into 36 12 times. 2 times 12 is 24. It'd be the same thing as this. If you had 11 1/9%, you need to recognize that that is, what is a decimal? 0.1. 1 repeater. What is it as a fraction? 16 2/3%? 1/8 actually turns into a decimal. 1/8 is what decimal? 1/8 actually works out as a decimal. 0.125. Eighths work out. 6 don't, 7 don't, 9 don't, 11 don't, 13 don't. 14, does 1/14 work out as a decimal? You should know that. We use that in farming all the time. Huh? You plant 1/14 of an acre. What is that? Drew? This number 11. This number 11. Sketch the graph of the equation. Drew, I'm going to ask you what form is this equation in? Standard. And I solve standard form by doing what?
Cover one side up, solve.
So if I cover up the x's, 3y equals 6, 3 times what number is 6? So y, the y-intercept is 2. So at 2 you put a dot. That's 1 point. You need to find the other point. Cover up the y. If 2x equals 6, 2 times what number is 6? So x equals 3. So here at 1, 2, 3 is a dot. And then everybody is happy. When a plan comes together, what a mystery. That's just about them all, is it not? What? Wait, is that a question or are you asking how to do it, Mitch? How do you do 1/16? Just like if it were numbers, what's the first thing you have to do, Mitch? Add 1/3. If I add 1/3 to 2/3, I get 1, right? And now I have 2/3 x equals 1, and there's that ever-burning 15th billionth time, Josh Shelton. If there's a fraction in front of the letter and you want to solve it, what do you do to it? Which is what? I agree. Huh? Flip and multiply. Wait, kids, band people grab a test note there. So yeah, you need to flip and multiply by 3/2, multiply by 3/2, and that's your answer. Just cross it off. X equals 1 times 3/2, which is 3/2. They're good.